Yes. So, Uli, the word is yours, and you can unmute yourself. Okay.
Okay, you see my screen?
Yes.
Okay. Also, a big hello to everyone virtually. Nice to have a chance to give you an insight in what we are doing. And thanks also to Priscilla for the introduction. Because if there are questions during the presentation, I recommend that we have them at the end. But if there is something urgent, please raise your hand and Priscilla can make a watchdog. and you stop me when I'm too fast or something is not clear. We can discuss it on the way. Yes, I was asking myself, where should I start? What should I show you? And I decided to have a rough overview or to present you an overview, not making a deep dive to something because of the time. 1 hour is not the whole day, so you will get an overview about what we are doing. And first, so now that's the agenda. So I will shortly introduce my team and giving motivation of something we are facing at the moment. Then we dive a bit into the replacement of diesel locomotives and go to the construction side, what we are doing there. Then emission-free construction side, with a large deep dive insight into a few projects, so giving you a perspective what we are doing there, and at the end a discussion. That's the team. Basically, it's a small team at the moment. We are growing by 2 to 4 persons already this year because of the work we have to cover. You see here myself, I'm not only leading the group, also I'm responsible for all the battery topics for the SBB and infrastructure development. Then we have Marco Meyer for alternative drives and techno-economical assessments for solutions. Then we have the expert in alternative fuels. He is also representing ourselves in the strategy climate neutrality for SBB, which I will show you later. Then we have our expert for hydrogen and hydrogen-based solutions, as well as project leading for the project leading team. What Priscilla said, yes, it's like we are not only focusing on infrastructure, SBB or passenger traffic, we are working also with and for others and helping in joint projects if there are questions. We are connected internationally and has also from the Band vom öffentlichen Verkehr, a group which we are leading, Zero Emission it's called, where we try to show our expertise and help others to get on the same level. Because like BLS or Rätische Bahn, colleagues from there are smaller and don't have the team as we have. And so as SBB, we take the leading role there and helping them in projects. Also well connected to industry and other partners. So it's not complete, but gives you a view of how we are on our way. So the motivation for the change from fossil sources towards the final electrification, as I call it, of the railway system. Why final electrification? I hope almost every one of you knows SBB a bit, so I skipped the introduction of SBB, but not to everyone is clear that SBB is not completely electrified. The passenger traffic is 100%, so you will never drive a diesel passenger car from A to B. But when it comes to logistics or maintenance work, there we have a diesel fleet. It's 700 vehicles at the end of the day. So motivation is in German, and I have also some slides where I copied information in German in it, but I will explain it. And here, I just want to express that we are also in focus of the public. So if we pollute a little bit or we procure a diesel engine or something, it's directly in the media. So we are aware and have to be aware, and we get also the pressure from the politics, like from the Bundesrat, for example, Conseil Fédéral, that we have to be completely climate neutral, which is also a good motivation and driving force, as it is important to give a sign from side of SBB. And our answer is directly here. I don't want to go into the strategy and something like this, but you see, basically phase out of fossil energy sources also completely, and we will ramp up a lot of batteries. We made assessments of other technologies like hydrogen, etc. Here I'm presenting you only the amount of batteries. I don't want to go and make a deep dive in hydrogen or alternative fuels, which would be worth already a next event of 1 hour. You see here the timeline phasing out. So it's in speaking in railway time atmosphere, it's kind of tomorrow, because our fleet is living between 25 or 60 years, and the procurement takes from idea to get it done sometimes 10 years. So it's time to act. And you see, it's for most of you a number you know how to take it. 140 megawatt hours batteries capacity we're going to install. The diesel fleet is responsible for 40% of the CO2 emission of SBB. It's also what my team is representing and responsible for it to make that a change. I see there are questions, but I continue, Priscilla. Okay, good.
Yeah, there was somebody that cannot see the screen, but I think it's his problem because other people can see the screen. So
then it's okay. And you see here also hydrogen and synthetic fuel. It's written in German, but you know what it means. This is almost on our, we observe it, and we have there also joint projects. But everyone knows that synthetic fuels is far away from getting availability. But what we are going to implement is already end of this year, HVO, a paraffinic diesel, a blend. So we reduce the B0 diesel to 25% of a mix, kind of, from paraffinic diesel. Also there, I can give some more information in a separate call, or write me an email if you want to get some more details information there. But there's much more. When I go outside on construction field, no one asks me about CO2 because they don't care. Basically, they have to finish their work. But what they complain, the people outside, is noise, the pollution directly. When they work behind the diesel engine or lead. And we have also like around 400 noise complaints per year, where we have to go to the people, say sorry, and giving something which costs a lot of money. Then we have the pollution, NOx. This kills, as I always, this kills the people tomorrow, and not after the day of tomorrow, like CO2. So it's directly here, and the people outside in the construction field are aware of it. And so it means also we have problems to get people working on Sunday night, Saturday night, and kind of smoking this pollution, making some harmful things to their health. But there's more behind, not only CO2 emission. And basically, the electric drive is 3 to 4 times more efficient, lower maintenance costs, and there we have also economically motivation to move onwards for this electrification. And last but not least, with the crisis in Ukraine, and so we know what this means. It's also better to invest in Switzerland for renewables instead of cash out to other countries. We don't know where it goes. It's not only like a Swiss SBB thing we do here. SBB is also in partnership with other railways internationally, and there is also the sustainable green rail, which is a target to fulfill. And there, as SBB, we have a bit trouble, as you know, with Horizon, but we get fundraisers internally, and so we can also join projects here and realize things, pilots, and so on. But this is also motivation for our management to force this topic. It's not only the diesel fleet which is polluting. Here you see a rough overview, as it is also in the private sector, also in the public sector, building and heating, of course, something. And the biggest we have for third parties. We don't do everything by ourselves. We have also contracted third parties. I will shortly show you in 20 minutes a bit more details there. But this is a huge amount of CO2. It's double it's more than twice what is internal pollution for the diesel fleet. There we support as a team as well, like the third parties for their change. So going a bit more into the topic, it's a replacement of the diesel fleet and construction site vehicles. What this does mean. Questions to be solved. It's not also not making a step backwards. It doesn't mean implementing just batteries and the electric drives. That's not working like this. Some of you maybe are aware of it. There are questions to be solved. For example, I start here with nothing technical. We have to train the people to maintain things. We have to train the people about the new danger. It's rotating, but there's no noise. It's not the same when you have like a combustion engine, then you hear the danger. This is something. Then there are questions to be solved, like from the sustainability perspective. How do I recycle something I'm going to install now in 10 years? Do we know what we have in locomotive A, B, or C? So you have to track it and have already a concept there. Then fleet procurement wants to know, well, is it the right capacity? What is the scenario in 10 years, in 5 years, in 2 years? So we have to analyze a lot of data in the team at the moment and make a forecast. So there are a lot of questions to be solved, and we have the different teams growing for solving this, and it's also a complete new discipline for a fleet manager, for example. He has to think in a different sphere. And also to show you on more challenge on the next slides, and this is also one which a lot of people are not aware. Now people are driving just with diesel, and we have 2 fleets. That's those 2 which have already are hybrid, like a diesel and can go to catenary and drive under the electric grid. And they have a lot of incidents because the driver here has to focus, because he's driving by view, to focus the track, to focus the workers on the field, to focus something else. And you see the mesh here. It's also difficult to follow him where is still electrified or not when he's shunting. And there sometimes he has a sign here or on the bottom. And so we have per year, when we sum up for the forecast, like when we don't do something, 8 million damage in cost of steel. Already today troubles, and so we have to solve there this incident to make a forecast. Is there an electrified or not electrified? For example, the worst case is like the dynamic behavior of a construction field. Sometimes it's in burn, for example, or 10 kilometers after burn, and should shut it off because of maintenance work. And this is a rolling question. And there we have research ongoing, also with partnership with other railway operators, because they have the same problem, which is coming up now because we're going more and more electrified with hybrid systems. And it doesn't matter if it's a battery or a diesel at the moment. Something has to be solved like this. Then you have also the challenge to choose the right connector. Sounds very basic for you, but our infrastructure is existing since a couple of years, and it's in overall Switzerland. And the most common connector is the CE32, and our batteries will have the signs between 100 or up to 500 kilowatt hours. So as an example here for the construction fleet, we are going to procure 290 kilowatt hours. It will take 13 hours to charge it. This is not going to work like this. So we need to also upscale our infrastructure, which is huge. And so we have to think more than twice to make the right choice. And also it's interoperability. We have to make sure that other train operators can also connect to our grid and charge. This is given by law that we have to do this. And now it's like a huge work to speak to everyone and ask them what they want, what they need, and how is their charge system, and to define the new infrastructure to being ready in the future. Because we are going to have a huge amount of fleet. This is just on the bottom right to see some pictures, small pictures, but it gives you an overview about the diversity of the fleet. And those are not going to have pantograph. They have to be charged by infrastructure, so stationary charge. And they're moving around in whole Switzerland. So we can place a connector to charge them in each segment, because no one's going to pay it. So there's a lot existing. And you see, when you look at this picture in the middle, UEC 552, it's 800 amps. It's a huge cable. No one will be, also a few people will be able to move this around to charge the locomotive. There are also such aspects you have to cover. And in the automotive sector, it's solved like the juice box you see on the bottom. This is not also a bit a difficult part, because you cannot place or put on every locomotive such juice box case, because it will disappear, it will get lost or whatever. We have to make it unique and solving this problem on this side. Another challenge is modularity. We are having 700 vehicles. It does matter in terms of asset management. If we have 10 different batteries or just one in terms of management. So with the right system design, we can save basically money. And a typical locomotive is living, because it's designed for 25 years. Normally it's working much more than 25 years. We are replacing at the moment locomotives, they are 60 years old, which is good in terms of using this asset until really dead end. But this means we are going to replace the battery system at least twice in this time. So after 10 years, no one of us knows where we are with the battery technology. We are lucky that everything gets better at the moment. So small and lighted, this solves a bit the problem, also makes it easier, but it's not done like this. So we need to define the needed interfaces. So when I get the interface from a call it by the name or ABB or whoever, maybe is in the call, they're not happy if I go there later on to Akasol. They want to have their system again, the proprietary systems. So I have to define also with ABB, very good company, very good solutions, something which is also reliable in 10 years. Then voltage level is a question, data logging, etc., etc. And also second life approach. So it's a topic, you know, bottom left with EcoCenter. Maybe Michael is in the call, I don't know. We built this second life storage. We made a lot of experience out of this. The problem is not solved. How we define the proper requirements to be second life ready after the primary use. And we will have a lot of batteries, as you have seen some slides before, which are perfect, suitable for secondary applications, as we have as well at SBB. A lot of USPs. I continue with other challenges, like the general design. You see on the bottom left the locomotive, and you see here a flat area, and you know what happens when it's midday. It's summer, July, and how hot it gets. On the iron, the rocks, they get in summer much more than 40 degrees, up to 50 degrees. But also in terms of design perspective, a challenge for the industry to make it the right design. So also there we have to make a proper cooling system for when they're parked, switched off, or whatever, to have a suitable lifetime, not only 2 years. So the goal would be like going up to 10 years. Also fitting the components. Railway systems are heavy because of a reason, not just because we like it. There are a lot of things inside, and it's really a challenge when we try. There's an example here, project we face tomorrow again. How we implement in existing fleet batteries, because there's just no space. This was in terms of engineering a challenge, and choosing the right technology. There are a lot of possibilities, and there are all the advantages and disadvantages. I presented you in the last slide some challenges, and I continue like this, just to give you like really the bright insight, and also make kind of sensibilization, and also motivate you to develop your products in this side, and going with us in contact, a lot of experience, and can also help to make those systems ready for our needs. Next is emission-free construction side. This is a very interesting field, and also very advanced already, because we pushed it a lot in the last years. What we basically need there to enable the change are the tools and on the charging equipment. So the tools need to be robust. It's railway. It's heavy stuff they have to do outside during every temperature, cold winter wind, and so it has to work. And we have not a lot of time to work. Imagine the railway station in Zurich operates until 2 o'clock in the morning, starts again 4 o'clock. There's almost no time. So when we have closed the track, it needs to perform all the things. And what they don't like, even though the people working outside a bit used to carry on heavy things, but it's not okay when it's heavier. It has to be ergonomic, etc. And the powering the system is an unsolved problem at the moment. We have to equip the storage locations, the team bases with the right infrastructure. And we have in entire Switzerland different teams with different situations, and sometimes a lot of old buildings. So there, the change is ongoing, but it's a long time until we're ready to charge also the huge systems. which are taking a lot of power. The E2s are available. There happened a lot in the last 2 years. I'm happy that Robel, for example, here showed, it's also Geismar, they developed good products. 2 years ago, it was not mentionable, it was nothing. And there have also a lot of other railway operators asking already for them because of the reasons I mentioned before. The challenge is bigger in the electric vehicles. Just view here as a picture. That's difficult. It's upcoming. It's more and more, but not a high market penetration yet, because of the much higher invest costs. So there's not that pull as we have here. Everyone's starting here and moving then onwards here. So we have also to help a bit in industry at the moment, sensibilization and showing the products. We're also going this year already to face renewable construction sites, means completely electric, and we really try to collect on every sector trucks or evacuators, etc., dumpers, whatever exists, we take to show the people that it works. Then how we're going to power it, or you have to can imagine this year we start to maintain a tunnel close to Biel. Everything has to be shipped over by a ship. There's not a grid to power everything, and huge equipment will operate there. So we have to think about bringing over the electric energy. So we made an analysis because also the topic of hydrogen, what suits most, and it's a multi-dimensional optimization problem. We also seen that the battery is the most favorable thing for our needs. Hydrogen does make sense when we go up to more than 2 megawatt hours, which is rare, even though we are almost in every construction field, at least a small power source there. It's the same for dimensioning, and I'm also always happy to show this picture, also because of the hydrogen hype, I want to say, to make it a bit more clear. It's not everywhere better because everyone forgets that the system needed additionally fuel cell and tanks. So for us at the moment, after deep analysis, it's batteries in focus. Also in terms of usability. But it's the topic, and we have also the first hydrogen systems running already. But it's definitely a solution for a niche. Here you see also, we went outside 3 or 4 years ago on the tracks to see what they really need, how does it look like. We have a lot of gensets, diesel gensets outside. We classified them, then we discovered that there's a need for a small one, each genset has, it's already in rollout, to power electric tools like lightning or small screwdriver, etc. Then you have to discover each genset dam, where we made a project with the BFH own product. SBB, we have seen that there's no available product, and like this is also SBB working. If we see that there's a need and we need to solve this problem, we do it by ourselves. It's done, it's in procurement, signed yesterday. And then we have for the huge gensets, we call it, more market availability, more technology available. So there we go into procurement to power our construction sites. So I go to some projects. I showed you like the diesel fleet, what's going there, what's the challenge. I showed you the need on the construction field. Both comes slightly together as similar problems to be solved. And now a few projects, I think it's 4, not more. And then I would like to also to enter the discussion. It's energy packed, like the last thing I showed you. It's already now in procurement. Maybe some of you have heard about it. Otherwise, just watch CMAP or ask myself. I'd be happy to get in contact with companies providing solutions. This is basically facing one huge problem we have in the railway sector. We have not the amount like a car industry has. When we go to Le Clocher and ask for batteries, we ask for 10 pieces, or also in terms of vehicles. when Volkswagen or some else like in this region goes and asks Leclerc for a battery system, they speak about a few thousands, 10,000, 100,000. So you see that this makes it more expensive for us because we have also other requirements than the automotive sector has, and then we pay every time development costs. And this is a kind of pain for us, and makes it super expensive, and it's tricky for the projects to cover this. So what we say to the SBB, let's be the owner of modular energy packs, and then when we go to procurement, we say to the industry, we have to implement 2 or 3 sizes of this energy pack. So it's defined in slices. Sorry for making it in German, but on CMAP it's also in English. We want to have the module like the power electronics here with the data communication, and then the batteries itself as a standard modules with the remote access. This is the goal. We are going to procure and make it ready to serve the industry and help them getting faster electrified. What we did here is, this is going to be one of the biggest procurement for the construction field, kind of a vehicle. You see here the picture of the last generation. We took the last generation vehicle, made the data analysis, and checked which kind of technology we are going to need to fulfill our tasks outside. And there, we analyzed more of them, but those are suitable for us. When it comes to costs, which is not mentioned here, that's we were very happy that we got to the conclusion that battery with catenary is the one which fulfills all our needs and is implementable. Because of the energy density, we were afraid that we have to invest much more in hydrogen. But now we are happy that we are that much electrified. So when we go to the construction field, we can charge the batteries, work remotely, and then go back on the catenary. So this works. And now we go into the procurement of this vehicle and know which technology we have to procure for this kind of fleet. This is something we are doing in our team. Same for here, for the biggest shunting vehicle, which we're going to procure. Also could start already this year, latest next year. Then we went also outside, make data analysis, define the profiles, optimized how the use the vehicle to make sure that it fits when we're going to procure it with the amount of capacity we have been defined. And it's not just implementing a new propulsion system; it's much more. So it's a diverse operating profile we have to show to the industry so they can develop the needed system. And you have also problems with charging, or the challenge there, because they operate sometimes 7 days, 24 hours. And this is something we had to analyze deeply enough to make sure that the industry knows what we really want. As I mentioned earlier, we're going to be biggest battery owner in Switzerland in terms of kilowatt hours. So it cares in terms of money when we care about this asset. And what we're going to develop now is a battery manager to make much more out of this asset battery. We can procure it after 10 years. In lucky cases, we can throw it away, which would not be nice. So we say that SBB, we make more out of it. So when we're going to implement 140 megawatt hours, it's for us a small power plant. And we need to control this power plant, also to make sure that we don't destroy our grid, which is the most powerful in Europe in terms of energy. So we don't have the problem in parallel charging, because it's over the day it doesn't make troubles, but we can make much more. We can also when support the planning, for example, when there's intervention in terms of an accident or something like this, and the construction field vehicle has to go out, the fleet manager can look on his app, make a fast charging of the vehicle that has to go. So when the person arrives there, the train driver, it is charged and ready, or when our grid is weak, we can stop charging for a few seconds, what we are doing already. At SBB, we have a load management developed by ourselves. There we control by remote all heatings in all passenger traffic when we have peak power, which is troubling our system. Next step is also connecting it to the traction system and as well to the battery system. So the different aspects we are developing at the moment. This project is running very well at the moment, and it's also for the central asset management. It matters if we know the state of health early enough that we can start procurement, not the day after we decide we recognize that the battery or the state of health is not sufficient for our mission, and so we can actually manage this system. So those has been 4 projects. There's nothing more. To give you an overview also in what's going at the moment, what we are pushing, but quite a wide bandwidth we are covering. And I say it always like this: it's kind of a puzzle we are playing. Maybe just Hut is also in the call. I don't know. I copied your puzzle elements and inputted my things. So I will send it also possibly anyway. Have the presentation. It's playing kind of puzzle. We can procure only vehicles. We have to think also about this charging. If we think about charging in parallel, we have to think about the power grid. So it's a puzzle we have to flip on the same time to make sure it works. We should not forget the training as another example. This has to be worked out in parallel, that also the people using the fleet at the end or the equipment know what is different, know how they have to treat the batteries. Our firefighters have to be trained. We have to solve the second life problem before we get the first vehicle, and not when we have the first vehicle. We have to develop simulation model because of aging problem. That when the industry is saying us NMC is the solution for everything, we can go with them in discussion and say, no, we analyzed it and we know LFP is better, for example. But there's a lot of things we are developing at the moment. We need also help. You've seen this. The team is not 100 persons. We are at the moment 4, doubling the size by end of the year. But we need, what I want to say also, people in this call, solutions from your company maybe, I don't know, get in contact with us, help us to solve those problems. I think it's a chance for the Swiss industry, it's a chance for SBB, and it's the last step, I would say, to get public transport on railway 100% electrified after our grandparents electrified our passenger traffic grid, also motivated because of a war. But now we have the climate, and this is one of the drivers to make here this development. There was a lot of different topics. I hope not confusing everyone. Sorry for jumping around, but I decided to make this in this way and to give you a sneaky insight. What is happening if someone wants a deep dive? We are here and happy to show more. It's also good to speak with other experts, to speak with people not understanding or seeing it different. Only like this we can grow. And especially want to motivate colleagues. I've seen VBZ this year. We have to solve the same problems. We have to work together and not developing different standards and different modules, sizes, etc. Working together, making sure that those systems are running and not just feeding proprietary needs. Thanks for the attention, and yes, like this it could look like. Make out of the drawing a reality.
Yes, thank you, Huli, for the presentation. It was actually clear and interesting. So we can open the floor for question, and you can write it in the chat, or you can just raise your hand and ask Huli directly. And maybe as a icebreaker, I will start with one question. You already say that you will be the owner of the biggest capacity, so 140 megawatt hour. And you already say that actually on grid, you should not be overcharged since, you are not expecting to charge all these locomotive or battery in the field, and actually battery can also sustain your grid. But are you expecting to change somehow the existing grid, and what will be, the impact of the battery on the grid, both while charging and while operating battery for grid-friendly services?
Then we made a huge analysis in the last weeks, or months, almost half a year, because 3 years ago I ran to our grid operator. SBB is doing that by itself in Zollikofen. It's also interesting to know we have our own power plants, 90% renewable. There's another topic, and there I say that we have a risk. We seem to analyze with the proper data that it's not a risk, it's a chance. We are not because we maintain our grid during the night, and we drive during the day. The peak is in the morning, so that the vehicles, when they come back from the construction site and they have the pantograph, they can charge. So during the night as well, and then they go parked when the passenger traffic is coming, and the peak in the grid we have during 7 and 9 o'clock in the morning and 4 to 7 o'clock in the evening. So this goes up. This is okay, and we have our power plants are able to go up to 700 megawatt peaks covering this, and with our load management, we are sure that we don't have to invest in a future further power plant if we do it correctly now. The smart battery management.
It means that the recursive usage that you will have will help you out to optimize the system. Okay. So there is a question. So thanks for the nice overview. Can you please let us know if you have a short list of chemistry that you prefer for the intended application? So
as SBB, we are not. We should not. We should not say this technology is the technology of choice. What we don't ban technology. This is the first of all, but due to all analysis, we know, and most of you know that it's the way it goes over lithium. We have projects with self batteries, for example, so we test also other things, but lithium is the choice at the moment. And when you are aware of this and you would like to know a bit more about lithium, there we see at the moment, because of the heavy use, we have a huge power demand. It goes in the direction of LTU and LFP. LFP, I would say, is at the moment underestimated in the market. So this could help us because it's a good bridge between NMC and LTU. NMC, we have seen out of aging models, it's tough for NMC to cover our needs. But we don't say it has to be NMC. NMC, we don't say it has to be LTO. We don't say it has to be LFP.
So you will actually have modular system in terms of size, but also chemistry.
Yeah, chemistry. There we don't say it has to be this or this.
Okay.
But we also, when you go to procurement, we don't say to the industry 450 kilowatt hours has to be implemented. We analyze this internally to know if it's feasible and possible. Then we define a scenario and we hand over the scenario to the industry, so to motivate them also to think in energy efficiency. Because at the end of the day, if you design a battery system, you have to think first about energy efficiency, charging, and then you have to define the capacity.
And cost, right?
Then yes, exactly. So when you have efficient systems, you can redimension your battery system, and then you save also money at the end of the day.
Sure. There is another question. I'm sorry, but I cannot spell very well the name. So it's Kevan Shokov, and he's asking what is the preferred charging strategy? Is overnight, or you had in mind something else?
The preferred charging strategy is whenever it's connected to grid to make slow charge. We are thinking about making per default 1C. If the grid gets in trouble, we completely stop charging by the battery controller, or we reduce it slowly. But we would like to give to the person which is or planning the trips or the train driver the possibility of his handheld he already has now to make a fast charge, and this depends then at the end of the day of the technology, because for intervention it's important. But we don't say it has to be during the night or during the day. This is not the choice, but what we also could do, and it is in the project, market-oriented charging. seen that there is not that much saving potential, but will be an opportunity.
Yeah, so another question from Sentilantam Mariapan, and he's asking, if there is a plan for vehicle to grid integration with bidirectional power flow.
Yeah, this is a recommendation. It has to be bidirectional. And every train you're driving, I hope you drive a lot of trains privately, also for work. When we brake, then we feed back the energy. In the newest train, everything. It's not brake like the cars or one thing with the iron on iron until almost the end when it comes to stop back to the grid, because we have AC grid and huge traffic, so it's no problem to feed back always. So it's kind of bidirectional system already today, and the locomotive as well. The problem is a bit in the standstill when it's no movement with evaluation of the tension of the voltage. I want to say there. When it stands still, that's another other issue, but it has to be able to feed back energy.
Yeah, and I think this goes into your load management strategy.
Yes. Yeah.
There is another question from Stefano Esperanza from Designwerk. So hello, Yuri. Thank you for the nice presentation. With the massive cost due to the highest capacity, you mentioned to make more out of the cost. Are you interested in using the battery system parallel with other application? Or what is the idea to make use of the huge investment feeding grid?
Other application, you mean?
I think other services. What are the other services that you will propose?
Kind of this. That's the answer. Maybe I was a bit too fast here. There's more behind it. I can't also show it. It's a huge project, but this sums it up. I hope it was.
Maybe you can repeat it again so that it's actually locomotive that will have battery, but the battery in the locomotive will also serve the grid, and for sure we'll try to stabilize it. So
yes, this regulation frequency hold, I don't know how to say it, for this, for example, or to feed back energy when it's needed, and fast charge, slow charge to control a bit, and energy market orientated charging algorithmic. This already has been simulated, and we know the invest we have to take and what we get out of it, and it's a nice numbers. So we follow this project and because of the huge potential.
So again, another question regarding to the vehicle to grid before. So I specifically meant the question vehicle to grid for stationary vehicles with large size on board batteries, as the changes the dimensioning of the battery from lifetime point of view. Okay, I think it was.
Yeah, we there made an estimation about the lifetime and the effects we are going to have, and it is a question not solved. What does it mean when infrastructure energy, also those who operate the power plant, the other division, connects over this battery manager to a fleet which is not owned by SBB, for example, and we control this vehicle? Who pays for it if it's a degradation? We made the analysis and the effects, and we have seen there's no effect to it because it's not discharging 3C over those 20 minutes. You can. It's not the need we have in the grid to stabilize it. We have a few seconds to cover, and with the huge amount of locomotives we have on the same time on the grid, it's sufficient to discharge it, for example, with 1C or just stopping the charging. They were not happening a kind of active trading, for example. It's just the potential we have seen is not that huge. But what we still do is thinking about who owns the battery, and it could be because of the huge interest of other operators that SBB is owning all SBB Energy is having in their assets all the batteries and are responsible for the replacement, are responsible for the monitoring and the misfunction and maintaining. This would solve the problem, and then they could do whatever they want.
This is an important point, actually. I agree. There is another question more on the high level. So it's from Keivan Shokov. How do you see the future in Switzerland? Hydrogen or rather batteries or a hybrid
Yeah.
form?
It's definitely, I go up here. And on the way I go to the slide, I would like to really to underline that we are technology open. So we don't say we ban whatever, but we made a huge analysis about hydrogen, because when we started with diving into the vehicles and assessing the technology and seeing the profiles they have to do, as I said, sometimes 7 days, 24 hours, we were so out of sure that we can cover everything with batteries. We were not surprised a bit that and happy to be wrong. That hydrogen is not necessary for a mentionable amount of fleet. It will be necessary for will be a discussion for such special vehicles because there's a huge need of energy. But there we say at the moment, to invest in a hydrogen system, we have a lot of own filling stations overall in Switzerland. To change to hydrogen filling station would cost us that much of money. No one can pay the railway at the end of the ticket because it's a huge investment. We rather go first step with a paraffinic diesel, and the younger the fleet is, or with the new generation of the engines, of the combustion engine, we can use up to 100% HVO paraffinic diesel, so we can reduce CO2 already by almost 90% if we care only about hydrogen, what it means for NOx, noise, etc. We watch out for synthetic fuel as well. We are sure at the moment we never have the chance to get there with a reasonable kind of money, their access to it. But hydrogen is parked, battery is the focus, and this is everyone compares us. Also, some people compare sometimes with Deutsche Bahn or SNCF. This is not possible because we have a huge electrified grid, which others doesn't have. This is an advantage, and we say that SBB that we rather go in the direction to change how we operate something before we start investing a lot of money in hydrogen. And I would say, I hope political people in Switzerland stay like this, and we don't go in the direction like the Germans. There's a lot motivated by influencers. We made the calculations, and it's horrible.
Yeah, but I would say it's more European willingness to go towards hydrogen and not lose the know-how on it. And actually, I will say that that Switzerland has one of the most electrified grid, but if you think whenever electrolyzer will be cheap enough and scalable and modular, it will make sense also for Switzerland to go towards hydrogen because you can produce it locally where you need it with an electrolyzer and just feed in your fuel cell or
we made
hydrogen
a lot
system.
of calculation. I've seen that the huge costs for electrolyzer and producing hydrogen is in the cost of energy of the source. Like this is a huge amount when you make the split of it, and there you will never have a chance to compete with a battery powered system because it's just much simpler. It's in every hydrogen system you have a battery to implement. And also electrolyzer, we have projects. We are going to invest as SBB. We have also partners where we're going to help to produce hydrogen because we have a huge grid. We are renewable, and the idea is more in terms of the energy strategy that we use our grid as a battery. During the day we need the energy, and during the night not. And renewables like PV, when you have a huge roof and kind of place a lot of PV, it's producing during the day. So we take an electrolyzer needs to run at the moment between 7,000 and 5,000 hours to economically makes sense somehow. And so we take in the overshoot of the PV in our grid, use it, and during the night we feed back to the industry, which is interested in producing hydrogen, and so they can produce economically hydrogen. This happens already at the moment, but for all needs, we try to isolate it a bit, but we help the other operators with the huge vehicles, the other ones, the yellow ones, because they have no chance with batteries. They need more than 1 megawatt hour, and this just doesn't fit. And those advantages of hydrogen, they are known, like fast charging, kind of, when you speak in energy. Those are arguments. We should not forget it. But if you go down to numbers, you see it's nice, but it doesn't fulfill all our needs. So battery is the focus.
Okay, so I don't see any other question in the chat, but maybe last one from my side in terms of safety, around battery installation for SBB. What it is the concern? What will be your measure for
for batteries itself?
Yeah.
Yeah.
So you say that LFP
Yeah.
will be the preferred one that is intrinsic more safe, but
Yeah.
since you don't exclude also other technology, do you think you will have different concept regarding safety with respect diesel and now new system with electrified drivetrain with batteries?
Yeah, it's a wide discussion at the moment. I understand behind it that the battery system is much more reliable than a combustion engine because of amount of elements you need to propulse. So the risk of failure is less with a completely electrified vehicle. This is one thing. And then it's also about the certified and tested equipment. And also statistically, with the not that much numbers we have already, but you see also in the passenger traffic that in terms of really incidents, battery also full battery powered systems are less failure prone than combustion engine vehicles and burning, etc. But nevertheless, what you're going to point out, Biskil, is an important thing. It's we have to think about how we store batteries, what we do when we have a fire. So we in a tunnel we have a lot of tunnels. What we do when a fire has happened and how we take away the battery. This is on a good way to be solved. But what we are at the moment, because the solutions are here, mostly known, but we need to transfer it to the people outside. A lot are a bit because they're reading 20 minutes are afraid, and so we have to. It's a huge work for our team to speak and explain. And I'm happy to EMPA. Hopefully someone is here. Giving more of good reports and testing and showing, and we're also going to visit you with a delegation of ourselves. That's the way to go, and I would like to motivate everyone here. If you see some videos in YouTube or medias or whatever, help with us to communicate there correctly and sensibilize the people that what we are going to hear is less harmful to everything in all perspectives than what we are using at the moment.
True. So last question maybe we take, and after it's 4 minutes to the end. So you mentioned second life use. Is there already a strategy for when the batteries become available?
When become available in terms of time?
Available.
Yeah. You see here on this picture when we're going to ramp up with battery. The colors are because of infrastructure, passenger traffic. Not explained. Sorry for this. But then plus hopefully 10 years, and then they come out. Now the people think also we are happy also to join CircuBot, for example, if someone is here, I don't know. But people think already, okay, so we have time. This is not true. We have to define now what we do later on, because it's too late when we have the system in our hand after the primary usage. And what we do now, we miss then the communication interface. We miss then to log the data, because we want to know before we go in a second life application, is it still reliable? What has happened? Because when we go in a second life application, it will be mostly in a USP. What's the name in English, or USV-Anlage?
OPS.
OPS, sorry, exactly. And so the system has to be reliable. And now we need to have the correct definition. We don't have at the moment, and I know no one has it at the moment. I sometimes think it's a huge PR, and I'm happy to get in contact with people which know the solution, what we have to specify to be second life ready. But we need to do it, not only because it's nice and saves us money, we have to do it as the biggest owner of batteries because of environmental issues.
Yeah.
So 2035, it starts. When the system lives 10 years.
So it's Kevin Shokov. They say that I would like to invite you and iBAT to visit IBB battery production in Baden, if not done by now. So
I've done it and very impressed with IBB, and especially I will be happy to dive a bit more deeper into technology questions. And here's my email. Where is it? Here, contact me. Maybe you will get the presentation anyway.
yeah,
Lots of things to be done. We are happy to prove your concepts and help you to challenge the real world. Going away from PowerPoint, going to the trackside. There you discover where you have to improve your systems, I tell you. Thank you for
So,
attention. Thanks
yeah.
for moderation, Priscilla.
Yeah. Thank you, Huli, for the nice presentation and the nice discussion actually we had. And yeah, I thank all the participants and see you in a month with yeah, the BFH Energy Storage Research Center presentation. So thank you. Have a nice afternoon. Bye.
Bye to everyone. I send you the presentation. Have you skill or not?
Yeah,
PDF.
thank you. Yes.
Good.